All right, line S1, learning task number 4. We're going to talk about maintaining HVAC controls. It's a relatively short little section that we have over here. A couple of things for us to go and deal with on maintenance on these. Not usually things that we have to do for customers, but things you will need to know for yourself. And sometimes in the process of troubleshooting, you're going to take care for customers as well so that you don't get these recurrent trouble calls. Filters. Filters are going to be a big thing because filters are going to go and change our amount of airflow, right? If we have an obstructed airflow, that means that my motor is going to be pushing much harder, which means I'm going to be drawing a lot more current, which means that I can get to overloads off of those things. You need to go and make sure that your customers are cleaning the filters, both for the sake of the motor not burning out on their furnaces, as well as for the fact that we're otherwise able to get over temperatures that we will get inside of the heat exchanger, right? Because the filter is going to be directly ahead of the heat exchanger. Blower motors themselves don't need a lot of maintenance. They're usually self-contained units. You can clean any dust off of them, vacuum them out. You should never be using compressed air to clean stuff off because that drives debris further into, cracks and crevices, particularly in motors and the windings. Always start by vacuuming, and then once you got, the big stuff all vacuumed out, you can blow off the rest usually. But the stuff that we are going to talk about, the biggest, is going to be what's referred to as flame-proving devices. Most of our appliances are going to be gas-fired when it comes to heating. This could be hot water tanks. This could also go and be your furnaces. What we need to do is we need to go and prove that there is flame, whether it's going to be for the pilot light, which we talked about for the thermocouple, or whether it's going to be for the actual burners if we have other alternate types. We've got 3 main ways that we will light a burner. Once again, let's go and start by taking a look at what a burner is. A burner is just going to be a manifold. A manifold is going to go and be a tube that is going to go and have gas inserted into it, an air-gas mixture, and then it is going to go and have small little jets or holes over there. And when we insert the gas into there, we need to go and make sure that we've got some way to light it. One of the ways that we light it is going to be through the use of a pilot light, and a pilot light is simply going to be a smaller, ever-present flame. Okay, it's going to just be burning off of the end of my pilot light over there, and what we will have anytime that we've got a pilot light is we are going to have a thermocouple. That's going to be one way that we go improve our flame, and the thermocouple is going to create, because it's going to be a small thermoelectric value of voltage, it is going to go and create a small amount of voltage that is going to go back to my main gas valve. I'm going to have a main gas valve, and then I'm going to so this is going to be the safety, this is going to be the main. We'll call that MV, we'll call that the safety valve. And so my gas comes into the system through the safety valve, goes into my main valve, which we control for our system, and then from the main valve is where it goes and gets piped over to my actual manifold itself. Draw that so it looks like a single line. If we have, and we're just going to take this one over here, line's got to go up there as well. So this is what we normally are going to have coming into here. We have gas that will make it through the safety valve. Past the safety valve, we will tap off, and we will run a small amount of gas up here to my pilot device. Whatever the pilot device is, it is going to run continuously. Now, my main valve, this is what we would call for heat from, which would allow the gas through into the manifold to go and light that thing up. As long as I have got flame over here, over top of that thermocouple, the thermocouple will generate values of voltage. And the small value of voltage is going to hold open a valve inside of here, allowing gas through. If, for whatever reason, this pilot light goes out, once again, could be a hot water tank, could be a furnace. If, for whatever reason, it goes out, this thing will cool, and when it no longer has heat, it can no longer convert that heat into electricity, so I will no longer have voltage, which means that this will now go and shut off my safety valve, taking out the gas. So there's no gas leaking in, which is great because right now if I would call for heat otherwise, I would be able to call for heat with no pilot light. I'd be able to dump, large amounts of gas out into the atmosphere of whatever my place is, my installation is going to be. So this is going to be a flame-proving device. Let's talk about maintaining these ones. For a pilot light, a couple of things that cause these things to go out. One of them is going to be that orifice, the small tiny hole that is going to be on the end of your pilot flame gas supply can get ashed over. Small amounts of ash that build up from natural gas All you need to do is clean that thing off. Don't go scrub it with like a metal brush or anything like that, but just give that thing a quick little wipe and a blow. Don't press down because you don't want to shove stuff inside of it either, but just a light little wipe to try and take everything off of that one. You also want to go and adjust your thermocouple. Thermocouples are usually going to be mounted onto thin pieces of metal so that they don't carry a lot of heat to other places, right? It's going to be a large metallic piece over here, and if this thing is bathed in heat, what happens is that it would carry back to other stuff. What happens too over time is that these things can go and warp. There's a lot of heating and cooling cycles, so these things will warp, and sometimes they push out of the area of the flame there, so you sometimes have to put them back in. Or it could be that the orifice is starting to ash over, and so it's changing the shape of the flame. Just make sure it's fully bathed inside of the flame. Some cases you also have got an additional shield that curls over top so that the flame is going to be forced over top of that. You can adjust that flame shield to once again make sure it's completely bathed inside of that pilot flame. And the last thing that you can get is ash buildup on the actual thermocouple itself, which we refer to that as scale. You clean the scale off. That's all you need to do with it is just go and take that scale, clean it off so that it doesn't have that insulating layer. Little thin layers of ash will act as small amounts of insulation. It can be enough that it drops this thing out. Some cases you just have to replace the thermocouple itself. Usually appliance repair places will do it, or in most cases the homeowner just buys a new furnace because they don't understand what's going on there and they don't usually call you in for it, but those will be places to go and check. Other reasons that you could have lost it is if I have got covers off on my device. Sometimes if there's like a natural gas shutdown or disruption, you get small earthquakes here, and the gas systems will shut down because they don't want to be leaking gas, so people's pilot lights will go out. And then what people do is they open up the side door of their furnace or of their hot water tank, and because it took them so long to find that stupid screwdriver, they'll just decide to leave that cover off. Covers need to go back onto these things because the covers prevent us from having backflows that are going to come down the B vent, that's the chimney, push through the actual device and push out of that little door. If we have that, those backdrafts will be able to blow out pilot lights in a lot of cases. So make sure those covers are going to be back on inside of there. That's when dealing with my thermocouple over there. Now, we don't have pilot lids for everything. We've got a couple of other types of devices as well that are going to go and use what we refer to as igniters. An igniter is going to go and start up the gas. We don't keep pilot light running inside of there. Two main types that we are going to go and have. We are going to go and have DSI, which stands for direct spark ignition. It's like the spark plug inside of your vehicle. Basically, there will be 2 points of high voltage, and in between those 2 points, we will strike an arc, and that arc will be directly across one of my jets that I'm going to have. And when it goes across there, it's going to go and light that gas that we will have. That's your direct spark ignition. The other one that we have is referred to as a hot surface igniter. Hot surface igniter is going to go and be usually, it looks kind of just like an element like that. And it might be flat. It's kind of a silvery looking type of metal. What it is we take metal, specific types of alloys that we can heat up using very low values of volts and current. We can heat them up to the point of glowing, of incandescence, where they will glow white hot. So when we want to ignite something with a DSI, we send a signal to the with a hot surface igniter. We send a signal to the hot surface igniter. That thing glows white, and once that thing glows white, we monitor that through the currents inside of these systems. Then it is going to go and release the gas, so that that gas can be ignited by it. Whether we are using this or this, we need to have some sort of a flame-proving device, and a flame-proving device is simply going to be another thermocouple. It's just going to be inserted into a different section of our controls. So we're just going to put this thing inside here. They usually are long, skinny probes that go over top of multiple gas burners, the actual gas orifices over here. Those flame-proofing devices need to be bathed inside of that, and they need to look for heat. They know that initially they're going to be cold. So what they have is there's always going to be my signal for the ignition, and then there's going to be a small amount of timing that's going to go and happen. And during that time, it should be heating up. And if at the end of that time, usually no more than a couple of seconds or a second, if it does not sense any heat off the igniter, it's going to go and shut that thing down. Some of them will go and attempt restrikes. It's very common in a lot of gas-fired appliances that they will do a 3 restrikes. 3 strikes and you're out, basically, type of thing, where it'll try, and if it can't ignite, then it'll try, wait a little bit. They won't start up right away. they'll usually run a fan to dissipate any gas so we don't have, huge amounts. And then it'll try again, and then it'll wait, and then it'll try again. And if we can't get that thing going, then it's going to go and shut down. If I have got a DSI, so let's start by taking a look at direct spark ignition, where I'm going to go and have two probes that are going to go across. Or in a lot of cases, what's actually happening is we're going to have grounded metal that's going to be attached to my manifold, and then we are going to go and have the actual spark probe itself, which is going to look like almost like a unbent spark plug from a vehicle. What we have is we're going to have a cable. It's usually going to be really flexible. It's kind of like your meter leads. It's going to be that really, really soft silicone rubber type, because it's used for high voltage. And we're going to go and have that's going to be running a high voltage conductor through the middle there. What you need to make sure is that these things are, first of all, they're close enough. In a lot of cases, the metals will once again warp. Make sure that they're close enough. Make sure that they're directly over top of an orifice as well. They haven't moved over top. And make sure that that orifice is clean, because if there's no gas able to make it out of that orifice, then it's not going to be able to go and ignite anything inside of there. So check for all of that. The other one to check is your cables themselves. If the cables get a little bit pinched over time, they can actually arc out through the side of these cables because it's high voltages we're using for them. Adjust the spark gap is really the biggest thing. You're going to have to try an ignition cycle. You're going to watch where that spark is, and you're going to say, yeah, the spark looks good. I'm seeing good spark, and it's over top of that. It's got to be something different or whatever it's going to be. If it is a hot surface igniter, all you need to do is verify that that thing heats up to the point of being white hot, and that once again, wherever that thing is sitting over top of, that those gas orifices are clean, so that we can actually jet some gas onto the white hot surface to go and start that thing up. Some of my DSI, direct spark ignition probes, actually incorporate the flame-proofing device into them. Hot surface igniters never have the flame-proofing device inside of them. Those are always going to be separate, but sometimes you will see them where the DSI and the hot surface, where the flame-proofing and the spark are part of the same thing. All right, that is it for our maintenance off of these.